Okay, so we're going to do the first example. The partial pressure of nitrogen in air is 592 torr. Air pressure is 752 torr. What is the mole fraction of nitrogen? Mole fraction is always the part you're trying to find over the total. So for this one, if we're going to use the formula that's on the previous slide, the partial pressure of N2 is equivalent to the pressure that N2 is exerting over the total pressure in the container. Or actually, this isn't in a container, this is in the air. So pretty simple. We're going to take the partial pressure of N2, and that is going to equal 592 torr over 752 torr. So our partial pressure of N2 equals 0.787. Now, remember, mole fractions don't have units. Okay, torr canceled out here. They don't have units because what it is a part of a whole. It's a fraction of one. And you could move the decimal over two places and see that it's nitrogen is 78.7% of the air. And so mole fractions have no units. Now, as for the second one, second question on that same slide is asking you, what is the partial pressure of nitrogen if the container holding the air is compressed to 5.25 atm? So we've changed the pressure here. And now we're wanting to know what is the partial pressure of the nitrogen. So the pressure of the nitrogen, if we rearrange that same equation, equals the mole fraction of nitrogen times the total pressure. So it's the exact same equation, just rearranged to solve for the partial pressure of the nitrogen if we know the mole fraction and the total pressure. We just found the mole fraction in the previous problem as 0.787. So if we plug everything in, our pressure of N2 at, we know the mole fraction is 0.787. And we know the new pressure is 5.25 atm. Therefore, the pressure of N2 is 4.13 atm. So it's always the part over the whole. Mole fractions have no units, but then that mole fraction can be used to find the pressure of the nitrogen if you know the total pressure, either of the nitrogen in a container or in the atmosphere, whatever the question is asking.